Hi folks, and welcome to another DIY project. What's this? This is a camera slider that I built not so long ago. Probably the hardest or best or biggest DIY project I've done so far. For those of you that don't know what a camera slider is or what it does, I would strongly recommend you stay to the end of this video and check out the video footage. For those of you that do know, hang in there as well. Now, what I'm going to do is I'm going to go through each piece, an area of it that I feel is important, and I'm also going to show you wiring diagrams so that you understand how to wire this system up electrically so that it works. This particular slider is, and I have to mention this, is from Matt on DIY Perks channel, YouTube channel. Now, if I would strongly suggest those of you that don't have one of his built, that you go, if you're starting out from scratch, go to DIY Perks on YouTube. Matt is his name, and he is the one that designed and built this slider. I built his. He left the copper a copper colour. I decided to go all black. Personal choice. It has nothing to do with whether it's better or worse. I then extended his version, which is a manually operated, in other words, you do it with your hand, manually operated, to electrical motor operated. I added a few little extras to it as well, but I strongly suggest you go and check his channel out first. And thumbs up to him for a brilliant project. So I built it and then went further by electrifying it. Okay? So where do we start? When you have yours built, if you don't already have one, and you've checked out DIY, then come back to this video and I'll bring you through the rest. But for those of you that do have one built, brilliant, you're way ahead. So let's go. Where to start? This end, the power end of things. Now, you may notice this monster of a battery here beside me. I'm not going to be using this all the time because this is too heavy, it's too cumbersome to be carrying around. Especially if you're trekking through woods or forests or whatever. This is just way too cumbersome. Plus you have this extra lead on it and no. So what I have done is I've ordered a 12 volt, a small 12 volt pack that I'm going to mount on the actual slider permanently. I'll mount it opposite to this guy here, this control unit, over this side. That it's permanently wired in, it's permanently there. All you have to do then is plug in your charger lead, which this socket will then become, rather than the main power point. It'll be the charging point when I do eventually get this battery. Now the battery itself is about the length of this control box here, and it's only about 20 mil thick and about 65 mil wide, so it's about the same as that, about the same length. Get a little black box, say a 30 mil box that I can bolt on here permanently and put the battery into the little box, close it off, and just have the wires going out underneath then, neat and tidy. Okay, so that's to finish it 100%. It'll be finished then. I may actually do a little follow-up on it just to show you it. But anyway, to start off with the power end, this whole unit here, this is basically a black box with nothing in it. When I got it, you can get them in any good electronics hardware store or Definitely on eBay, no problem. I'm a big fan of eBay. Basically, this box was designed for the electronics guy that wants to build his own AC adapter or power supply unit or something like that. So it's a blank box, nothing in it, €2-3 to buy. That's it. I obviously went for black because the rest of the unit itself is black. Now in this then I mounted a switch for powering it on and off, and then I mounted a speed controller, a little DC speed controller. I think it ranges from 5 to 30 volts or something like that. Again, I'll show you pictures of all of these things. On it then there's a little switch, a directional changing switch. So press it that way, the tray is going one way. Press it the other way, it's going the opposite way. And then in the middle, it's doing nothing. And it's just sitting there. This is like a dimmer switch, like a volume control. If you like, you can turn it, and it does switch on and off as well. Now, you can't see anything happening there at the moment. That's fine because I don't have this switch on. But if I do switch on, well, before I do, this guy here then is a little volt and amp meter. Again, readily available on eBay. Pittance money. I think I get €5 for it. And I think this was €5. That switch I robbed off something else. It's a single throw, single pole switch. This is a double pole, double throw switch. But this comes with the actual speed controller, so you don't have to worry about that. I think the speed controller will work up to 3 or 5 amps, one or the other. So it's only a case then of laying it out as you want, your design. I mean, you don't have to follow exactly what I've done, but this is the way I opted for, and you basically cut out the plastic to fit these guys in, and obviously the neater you do it, the better it's going and more professional it's going to look. Now if I switch it on, right, and our voltmeter and our amp meter in blue lights up. Now the amp meter is showing 0 amps at the minute because there's nothing working, right? So there's no power being pulled from the battery. The battery voltage is 12.2 or 5. It's hard to read it upside down. So that's fine, telling me the state of my battery. This guy here then, as I say, is like a dimmer switch or a volume switch that you can actually turn it, and it's off at the minute. I put a little LED down here. You'll see it come on. See there? Right? And the more you turn him up, the brighter the LED gets. And that's kind of giving you a visual of where this is actually set. Now there is a little notch on it to say, you know, like a volume switch, and you could put little white dots around here on the plastic, like a volume control, so that you know exactly where you are when you switch it on. But I didn't bother. You could put L and R on this switch here to show left and right motion. I didn't get round to that yet. I'm going to. Now the LED here is extra because there is an LED on the actual speed controller itself, and basically you can't see it, so it's of no good, and it does the same thing as this one does. So I just basically tapped off it with another LED, an orange one. The one that's on the board is red. I tapped off it with this orange one and bored a hole in the box and mounted it and wired it in. Right, so that when I turn up that, I have a visual indication of what kind of power is going to the system. Now if I flick the directional switch here, I just turn him down, switch that like that, and then once I start turning up the speed, and that's it with the pedal to the metal. And then the limit switch stops it. Okay? Then you flick the directional switch and away it goes the other end. And again you can now, believe it or not, it is actually moving, but it's so slow you can't actually probably see it, but it is actually moving. So if you wanted to do time lapse and have the camera moving very slowly, no problem. Okay? Goes to the other end. There's another limit switch. The whole unit is about 4 foot long, and you get plenty of motion and tracking on it. So it's an ideal tool to have if you're into the video business at all. Now, I know the burning question in all your heads is, does it work? And does it work well? Hang with me and I guarantee you will be pleasantly surprised at how well it works, provided you build it accurately, let's say. Now, as regards the driving part of it, the mechanics, I mean, that's the electrics end of it. And as I say, I will open this, show you the inside, and I will show you show a circuit diagram as to how this all connects together. Okay. The other thing on the electric end then is obviously the motor. Now, the motor is what's known as, again, these are readily available on eBay, no problem, but it's a 12 volt high torque 50 RPM motor gearbox combined. Right? So that's a 12 volt high torque 50 RPM. So at max speed you're getting 50 RPM revolutions per minute at the spindle end or the drive shaft end. Okay? It has 2 wings or lugs on it that with holes for mounting it. The shaft is 5 millimeters in diameter, and the pulley that actually goes on this is a 20 tooth 6 mil belt with a 5 mil bore. Now, what I mean by the 5 mil bore, I'll just turn that around here. There's the pulley, and the 5 mil bore is the actual hole that's in the middle of the pulley. And the shaft of the motor or the gearbox is 5 mil, so the two of them fit together perfectly. Okay? And there's little grub screws then in the pulley to tighten it onto it, that it holds and stays in position and doesn't slip. The motor, it was obviously exposed underneath, but it's not at the moment. But it was when I bought it and mounted it first. And I happened to glance up at the windowsill, and there was a bottle of shaving foam on top of the windowsill. And I looked at the lid of it and I thought, wow, that's cool. It was white, but I didn't mind. I could spray it black. I wonder, will it fit? And it actually did. It was just over the size of the diameter of the motor and deep enough to allow the motor inside. So I brought it down, sprayed it black, bored 2 holes for the nuts that was holding on the motor, and spun on 2 lock nuts. Job done. Cut a little notch in it to allow the wires out here. Right? And that's it. So it may not be watertight, but it is giving it a level of protection. You know, if it did fall or hit a stone or something like that, or muddy ground or wet ground or got a splash of water, this is going to give it some degree of protection. So that's the motor and the pulley end. The belt itself is 6 mil. 2.5 meters long is what I got, and it worked perfect. I had plenty left over. Well, not plenty, but I had about that much left over. The opposite end of the tray then, or the run, has another pulley, and that's it there. Now that pulley is what's called a free running pulley because it has a bearing in it. So when you put it, and again it's a 5mm bore, so it's the hole in the middle of it is 5mm. I think that was 5mm, or maybe it was only 4mm. But again, 5, 4, 3, it's up to you what size you get. I think it's 5, and I put a 4mm bolt through it, bored a hole in the timbers, MDF timber, to mount this guy, put a washers and that under to lift it away from the timber so that it can spin freely but yet be locked in position. Okay, so that's the idea of the bearing. Whereas the one that end that's attached to the motor has no bearing, obviously, because if it did it wouldn't spin or turn the belt. Anyway, what else did I have to do? I had to put limit switches then either end. There's one there, right? And there's another one here. The wires from this one here is running down along this pipe inside, and I bored a hole down near here to allow it to go down into the control box. Now, as I say, wiring diagram is following this as well to show you the details of how to wire it. Weight wise, you might be wondering, is it heavy? Not particularly, no. Now maybe when the battery goes on it, it's obviously going to add an extra bit of weight on it, but you put it up on your shoulder and away you go. You have no problem with it at all. So getting back to this drive end of it, there is a thing I had to do very different than, we'll say, the standard setup that Matt did on his channel with DIY Perks. Now I'm not saying his is wrong and mine is better, I'm right. No, it's just that this is what I had to do to make it work electrically, and to make it work electrically successfully, right? So what I had to do extra was I had to put in these 3, 1, 2, 3 little pulleys. You might be wondering why. Well, the reason why is that if you connect it up and you don't have those in, and the belt is just running between the 4 big runner pulleys, right? What will happen is, if you put any kind of weight on this at all, it'll start sliding down itself. If the slider is at a slope, it will start sliding down itself, and you don't want that. You want the motor and the setup controlling the speed of it. So to eliminate that free fall, we'll call it, ability, I had to put in these 3 pulleys here to act as a kind of a braking mechanism, right? Now, they don't stop it or act, you can't make them lesser or more of a braking system. They're just as they are. Basically all they are is 3 of the same pulley that's at this end, right? A free running on a bearing, and bore 3 holes. I'll show you this here. Bore 3 holes through the tray, 1, 2, 3, and obviously again you have to position them so that they're not touching the big runner pulleys. Those guys here, especially these 2, you're not going to be touching them, but these 2 here, you can't have it touching them. And the belt comes in from around the motor pulley, and it comes down along and just over this pulley in the middle of it. So you have to put little spacers and things in that to get them positioned right with the alignment of these big pulleys, so that the belt can come in, centre on this, but not be touching it, and go around the first pulley here, down and under the bottom one there, and back up through this one and out. Kind of an omega wrap. right? And on it goes then round the other pulley, back up and ends here. And the other end then comes to here. Now while we're talking about pulleys, these 4 big ones, this is a point worth mentioning. When you do get them, before you mount them onto the unit and run into trouble like I did, make sure you run an 8mm bolt through it, the bearing, and put washers on it, like you see on the DIY Perks channel, but have them away from the tray or the trolley, and tighten it up, that the nut and bolt is tight in the bearing, and then see can you rock the pulley on the nut, on the bolt. And if it's rocking at all, don't use it. If you use them, and if all 4 of them are that way, they're going to allow the bed, this part here of the trolley, rock like that, ever so slightly. Now, you mightn't be able to even see it. When I ran into this problem, and I couldn't see it moving. You know, I was sitting there physically looking at it and I couldn't see it move. But yet when I would play back any video footage that was shot with this, and you look at the horizon was at this. It was rocking up and down ever so slightly, like a seesaw. No good, can't have that. So there must be no play in these whatsoever, the 4 big ones. When you put a bolt through them and tighten it, see do they rock from side to side on the bearing. If they do, there's no point in using them. The other point and the other trouble I had was when I initially set it up, I had the belt here, the 2 ends. After the wrap was done, I had the 2 ends joining in here in the middle. I think you can actually see the hole there where I bored it into the MDF platform. And I basically get a clamp on it and holding the 2 ends of the belt in here in the middle. My advice is don't do that, because if you do, again, the trouble I had, and I suppose because there was play on the big rollers as well, it was accentuating it. It was acting like a seesaw, because the pressure was in the centre of the tray, and it was, so the tray could do this on the bearings as it was being, the pressure was being applied by the belt. So that's why I then put it out to the ends of the actual tray itself, right? And it's a case of just using 2 little right angle guys here, one here, with a little hole in them. Thread the belt through and put on 2 tiny little cable ties or cable straps or zip straps, whatever you want to call them, either end to hold the belt in position. With these 3 pulleys, when they're positioned properly and spaced out nicely, and again it's up to you, they will act as a braking, right, system, so that this guy, the tray, can't run freely when you actually put it at a slope, right? So talking about slopes and all that kind of thing, you may be able to see there I have legs either end that again is not on Matt's DIY Perks version. That's not to say that his is wrong and mine is right. I'm not saying that. What I'm saying is I wanted legs on mine, so because it's electrical, it has this belt running in it, and I wanted to have it clear off the ground. The legs hold it up. What are they made of? They're made from MDF. I just cut them out with a jigsaw, roughly shaped them, sanded them down, sprayed them with black paint, end of job, right? Bore 2 holes and aligned them with 2 L little right angle brackets in here and bolted them down to the MDF, the flat MDF here belonging to the motor, and then out through and out through here, and put on little bolts and butterfly nuts on them to hold the legs on. So I can spin off the butterfly nuts, take off those legs if I want, both ends, there's no problem, but I leave them on. The other thing I did different, and we've been talking about sloping it and putting braking and all that in it. Sloping is something you're going to want to do, and you will see that in sample footage that I'll be showing at the end of this. So what did I do? You could put it on a tripod, no problem. I have the hole here in the centre like Matt did on his, and I can mount it on a tripod, absolutely no problem. You can put ones either end if you like as well, the same as the middle one, and away you go. But I decided if I can get away without carrying a tripod around with me, why not put a built-in support or leg on it. So what I did was I put this guy on it here, right, and a rubber bungy lad here at the end to stop it from sinking into the ground, and this guy is extendable. So this one pipe here is the 3/4, same as this, and this one here is 19 mil, and the 19 mil will fit and slide in and out of the 3/4. Okay, this guy here is just basically a spring lad screwed on to the MDF to hold it in position. So if I want to use a tripod, and the head of the tripod isn't that secure, and like this is, while it's not very heavy, it's heavy, right? For a tripod in the middle here, it would be heavy, and when this guy would be coming back and forth, the head of your tripod might move ever so slightly, destroys the shot, no good. So what I did was, if I put a tripod here in the center and extend this leg down, I can extend it and take up any slack that it won't rock. And obviously you take it up on the opposite end, that this leg is pushing it over to whatever play is on the tripod head, and then you're away to go, right? When it's up on its leg, it'll be like that, right? I don't know if you can see that, but so that's the kind of slope it will give you. Extend this and it gives you even a higher slope again, so you could have it up kind of like that and it will still work, right? And again, it's all self-contained, it's all in the one unit, and it just clips into position. What else? Now again, unlike DIY Perks version, I didn't stop the bolts going through, right through. I didn't see any need to in my version of it, and I put nice fancy little, I don't know, I forget what you call them, little bulb type end nuts, nice little dome shaped guy to give it a nice finish, and again all sprayed black. But I just bored straight through 4mm bolts and put washers then between the pipe and him, the plate, in there to act as a spacer, and then I spun on the nuts. If I strip off all that, it's exactly the same as DIY Perks version, no different except for the legs. But if I take them off, the rest is exactly the same. So as I said earlier, if you don't have one built already, check him out, give him a thumbs up, subscribe. When you're happy with it and it works fine, then come back here and you can do the electrics. And I'm going to do up a diagram now, and I'm going to show you how it's actually wired. Oh yeah, so that I know, just one other little point here, so that I know this is level regardless what angle I'm at or on whatever terrain I'm at. I stuck this little bubble kind of spirit level guy onto the actual tray itself. So if I'm at an angle like that, but I want this to be dead level, I can up him like that, and by watching the bubble here, I know exactly when it's level and lock out the two butterflies either end, right? Another little thing you might want to think about to make life as easy as possible, right? Not that it takes the guesswork out of it. So Without further ado, let's delve into the electrics of it all, and I'll go through it and explain it. Okay. Alright folks, here we are at the wiring section of the video. Now, please excuse the crudity of my drawing, but it's basically just to show you the different components that's used in the control circuit for the actual camera slider. So I'll just go through each individual piece or component and explain what it is and where they are within the system. So this is basically my 12 volt battery here. It has a positive and negative. So basically at the moment this is external and it has a wire going out, positive and negative going out and plugging in here to the power connector that is mounted on the black box that I was showing you in earlier. That's the way it is at the moment. Eventually, as I said in the video, I will be putting the battery permanently attached to the slider, and the only difference in the wiring then would be I'd bring the positive and negative directly into the back of the connector here, to the positive and negative, so that when I plug my charger in here, the battery is connected directly to it and it will charge it. The next thing we have then in the box itself, control box, is this switch here. It is the main power switch that's down at the side of the box. Now again, you may decide to put yours in a different place altogether. Up here then we have our amp voltmeter. Now in the particular one that I bought, there's a big heavy red wire and there's a big heavy black wire. And then there's a yellow, a much lighter wire, and a red and a black, and those three are much smaller, lighter wires than the red and the black here, the big ones. Okay, so I hope you can see that there. Then we move over here to what's called the speed controller. Now this is the directional switch unit here, and what you mount that on the box as well by cutting a little hole, and the wires then they're wired, is dangling away from the actual circuit board itself, and there's a plug at this end here that plugs into the circuit board belonging to the speed controller. So just unplug that, cut out the hole for the size of the switch, fit the switch in and feed the wires through the hole and plug it back in here again, and you're way to go. Up here, this represents the silver knob or volume switch or dimmer switch that I was showing you in earlier, and that you can turn and actually switch off as well. That comes out through the actual box itself. You just bore a hole to allow the spindle of the potentiometer here out through the box, the hole in the box, and then there's a lock nut on it, and then you put down your silver switch down over. This here represents the external LED that I put on mine. Again, you don't have to do this, but if you want to, this is the way I did it. Bore a hole in the box to accommodate for the LED, put that in, and then run two little wires and just tap it off the existing LED that's already in on this board, and just tap off this LED from it, and you're way to go. At the bottom of the speed controller then you have four connections. Two of them represent the positive and negative input, right? Then there's two that represents the output. Now you can't label them positive and negative because they do change depending on the position of the directional switch here. So they do jump from positive, negative, negative, positive, and positive, and back and forth as you're changing this here. Alright? Then we come down to this piece here. Now this is very, very big by comparison to what it is in the actual box itself. This is a representation of a small piece of PCB board. And the white part here with the black dots in it, that represents the brass or copper rail connections in it, and the black represents the blank where there is no connection at all, and the black dots represent the holes. Now on this particular board you mount two little IN4001 diodes. They're very common diodes, there's no problem getting them. And you can see I have them drawn out here to show you the orientation of the actual diodes. Obviously they will be sitting in on the board nice and neat and tidy, but to demonstrate it for the purpose of here I had to bring them outside. So then what have we? We have the motor here, that's external, and then we have our two limit switches here, and you have normally closed, normally open, normally closed, normally open, and your common connection on both of them. And these guys are either end, as I showed you earlier, of the actual rail, the run. And the motor is external, so at the moment the battery is, so everything else, all this section here is inside the black box. Okay, so now we start, and I'm going to draw in the wires as you would actually wire it up, and I'm going to do it in black and red biro. We'll start off with our positive power. So our positive power comes from our battery, and as I say, it can be either via the plug that you plug in here, or it can go into it directly. So I'll just draw it that way for now, right? And then that goes straight over to the common of our switch, our main power switch. Okay, and the normally opened side of that, then you connect the yellow and the red of the amp meter. This is the two small little wires, the red and the yellow, and you bring them up, over, down, and in here. And this one goes the same way. The two of them are connected into it. Alright, so that when you flick the switch over, power runs up and in here. Now also you have to take a power from here up and over to the positive of our speed controller. The negative of the speed control, or sorry, the big black wire on our amp voltmeter, draw that in black, it connects directly to, I'll just jump that and over, and it connects directly to the negative of our power connector, like so. Now the actual negative of the speed controller, now this can be a little bit confusing, I really don't know what colour to draw it, but this is the big red heavy wire on the back of the amp voltmeter, and that actually connects to the negative input of your speed controller. So we'll just draw it in red, like so, and down like that. Alright. Now obviously the negative of the battery has to be connected, otherwise we don't have a complete circuit. So I come up with our black wire here and run it across and up into our negative of our power connector. Okay, the next thing we're going to deal with is our two limit switches and our little PCB board. Now you could have actually mounted these LED, or sorry, not these LEDs, but these diodes in parallel with the normally closed contacts on your limit switches if you wanted to, but just to save hassle in such a small little tiny area and the size of the little limit switches, I decided to put in the PCB board. But how it works is this: I used black and red wire, kind of speaker wire, and I connected the common of this limit switch, right? So it goes, the red part of the wire came up along and up and into this section here of this diode. And the normally closed side of that particular limit switch goes to the opposite side. So you come out like that and you go up, jump him over and in here. Okay, I put them in red. Well, that would actually have been black. Sorry, that would have been a black wire, because as I told you that I use red and black speaker wire. So this would be the black part of it. And it goes in to there. Okay? So it's basically across the diode, which would be the same as if I took that diode and put it down here on the limit switch, but I just put it on the PCB board. Now the other limit switch then, the common side of it, which will be red again, will stick with the same orientation. So it goes up here and it connects into this side. Of the diode, this diode, right? And the normally closed side of that then goes to the other side. So we would come a bit of a mess here, but anyway, bear with me. Wiring diagrams are hard to lay out neatly. And it would come up, jump that guy up and in here, like so, into this side of that diode. Okay. The same side of that diode then would be connected to one side of the actual motor. So we could bring that in red. Yeah, we may as well bring it in red. And that goes down like that, and down here, over and in there. Right. And the other side of the motor connects to this output of our speed controller, like so. With me so far? Now the other side of the output of the speed controller here, that comes out, jumps that guy down, jumps that guy down, jumps that guy over and up in here as well. Okay. Now, this all wiring diagrams, as I say, are hard drawn, have them neat. It's not like a schematic diagram, but you get the basics. One of the outputs goes directly to the motor. The other output goes to the diode setup arrangement on the PCB board. And then your two limit switches are connected basically across the diodes. And the other side of the motor then is fed from this side of the actual diode arrangement. So that's it, folks. That's basically the wiring diagram of the whole system. Now I'll quickly go through it again. 12 volt battery, positive and negative, red and black wire coming out, and it can either go as a plug-in into this 5mm plug-in connector or power connector, or you can wire it directly into the back of it at the positive and negative terminals. From the positive side, you take it straight to the common of your main power switch. From the normally open side, obviously, because you don't want this to do anything until you flick the switch. So from the normally open side of the main power switch, you join the red and the yellow small wires from your amp voltmeter to that, and also the positive input to your speed controller. So the three of those wires are going directly to the normally open contact on the main power switch. The big heavy black wire in your amp voltmeter, that goes directly to the negative, which is directly connected to the negative of your battery, either through the plug or the actual fixed connection at the back here. All right. So we have a positive input here. Now the negative then input from your to your speed controller comes from the big heavy red wire on your amp voltmeter. So you connect that directly over and in to the negative side, negative input on your speed controller. All right. So that's that section of it done. Then this section here, this little PCB board, and I will show you a shot of this and what it looks like. It's very, very small, very neat, very compact, and wrap it in insulating tape or electric tape when you are finished, so that it can't short out or touch anything else inside the control unit or the control box. So in my case, I use two core wire or speaker wire, which one side is red and the other side was black, right? And the common side of the limit switch, I took a red wire and brought it right over to this side on this diode here on the PCB board. And you can see there that both diodes are connected together, the legs, but they're opposite direction to one another. Basically what you're doing is you're connecting the switches in parallel, the limit switches in parallel across the diodes. And the normally closed contact goes to the other side of this diode here. Alright? And this limit switch then, the common side goes to this side of the diode here, and the other normally closed contact goes across and up here. Now it has to be on the normally closed, obviously, because these don't do anything or stop until they open that way, or this one goes that way when the rollers actually hit off them either end of the run. So it opens up, it stops the motor. Right? But because it's connected in parallel, when you flick the switch the other way, then it reverses the voltage and the motor starts turning in the opposite direction, and it goes back, and this switch will close again, and it goes back and opens this switch. And that's how it works. So one side of the motor is connected directly to the output of your speed controller. The other output of the speed controller then is connected down and into this diode here. Right? The other side of the motor then is connected from the opposite side of the other diode and out and down along. And that's basically how it works. So I hope you can follow that and it makes sense. If you wire it exactly like this, because this is exactly how I have mine wired, and it works perfectly.